Okay.
All right. So to figure out the cosine, we're going to use the hammer. Oops. Tap the brakes. So we get that. Cosine squared is going to stay cosine squared. Sine squared is going to be negative 3/5 squared. And that's going to equal 1. So cosine squared is plus, what do we got there, 9/15 or 9/25? Yeah. It's going to equal 25/25. I can't?
No.
Oh. Thought you were talking about me.
No.
So I got the cosine of theta is equal to plus or minus 4/5. Be honest, how many people forgot the plus or minus? Me. Okay. Right? Very important, because we were only given one condition. So we don't know what quadrant we're in. The only thing that we know is sine is negative. So that puts us down here, either in quadrant 3 or quadrant 4. Okay? So we need both of them. So the cosine of theta is plus or minus 4/5. Sine halfway around the circle.
Negative. Can't you just switch?
What?
It would be the opposite of sine theta.
Okay, because we're on the opposite side of the circle then, right?
So can't you
So
just
it's
do
still
3/5?
So if we're in quadrant 3, so let's say we're down here, we add or subtract pi, and now we're up here in quadrant 1,
Correct.
right? If we're down here in quadrant 4, then we're up in quadrant 2. Either way, the sign becomes positive, correct?
Correct.
So the formula that this is, and it's on your sheet, is that the sine of theta plus or minus pi. Actually, I think on your sheet, isn't it t? I think it's t on your, is equal to the opposite of the sine of t. So we would have negative of negative 3/5. So that would just be positive 3/5. Yes? Sine is negative 1/2. Oops, I should fix that one too. We'll fix that one in a minute. Okay? Sine is negative 1/2. That one kind of got scrunched a little bit. Okay? And we are in between pi over 2 and 3 pi over 2. So we're left half of the unit circle, quadrants 2 or quadrants 3. Sine is y. That puts me at 7 pi over 6. So theta here is 7 pi over 6. Questions, comments, concerns, clarifications, explanations. Okay? So sine is negative, right? Okay? So that puts me bottom half, 3 or 4. Okay? Second condition said we're between pi over 2, which is straight up, and 3 pi over 2, which is straight down. So that puts us left half of the unit circle. The only two that overlap are quadrant 3. So I'm in quadrant 3. Okay? So I'm looking for where my sine value, my y coordinate, is negative 1/2. which is right here, 7, 5, 6. Today we're going to bring back in our another tool, or I shouldn't say we're going to bring back in. We're going to dust off a tool in our toolbox, and we're going to talk about SOHCAHTOA. Okay? Okay? So the SO is sine. This is for any and every right triangle. This does not work on non-right triangles. So for any and every right triangle, we can say that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Okay. SOHCAHTOA. Now, with SOHCAHTOA comes the fact that we can now solve for certain angles, or we can solve for certain sides. Okay? So you will need a calculator for the examples that we go through today. Okay? Just so you are fully aware. Okay? Here we go. Okay? So it says solve for the variable. Okay? So how would I do this? How would I go about doing this particular problem? Well, I would say to myself, I've got this angle right there. That is going to be my theta. Then I decide what I have in terms of sides. I have the side that is opposite the right angle. That is always going to be the hypotenuse. So I have the hypotenuse. That rules out using tangent. Tangent doesn't use hypotenuse. Can't use tangent anymore. Okay? Then the side that is touching the angle is the adjacent side. So I have A and H. So, ka, or toa.
So, no,
Ka, right? Yep. I would use cosine.
My bad here.
So then we can say that the cosine of 39 degrees is equal to 23 over x. By x, and then divided cosine. So really, one mathematical trick is, yes, Evan's right. Multiply both sides by x, then divide by cosine of 23 degrees, okay? But really, what we can do is we can just flip-flop those two. Okay? So we can say x equals 23 over cosine of 39 degrees. Tell me what you get.
29.6.
So what did you guys get?
I got 29.6.
0.60?
If you round.
If you round it. Oh, I gotta go this way. I got 86.25.
What?
Why in the world?
That's so.
Alright, wait.
Don't look at me confused. I got it right there.
I got it right here.
I got it right there.
I got it right here.
I got the same thing typed in mine.
That's wrong.
That
Maybe
is
you just
wrong.
False.
Yeah.
I'm detecting.
I'll whip out the 1990s calculator, just really double check everyone's work here. Huh?
What's
I
wrong?
could throw this
It
thing
doesn't-
through the window.
What did you do? Wait, what is 29.6 times 3?
Under tree.
This.
Wait,
What?
Is there multiple modes?
What do you mean multiple modes?
You're in
earlier
radiant.
called this, exactly, but there are multiple modes I remember from geometry.
Yes, there are. Evan, what am I in?
You're in radiant.
I'm in radiant.
Collaboration.
Oh man.
Bro, I just-
So when you're like this really goes to work like if you're using our handheld calculators, the graphers, those are all in radiant.
Do we want to be in radiant?
Okay.
I guess the
What?
1990s. Do we want to be in radiant?
What was our problem in?
Degrees.
Our problem was in degrees.
No, wait,
So we want to be in degrees, right? Okay.
We're not even on the unit.
All
right.
We don't need radiant.
So we need to go back up, or I need to go back up here, and I need to make sure that I'm in degrees by using a degree symbol.
Will it automatically do that for like the next problem then? Keep it in degrees?
No, until I go change the mode. Yeah.
Oh, so you just do it
I
every
can do it every single time.
That's
Yep.
why I use this trusty Texas
Yep.
instrument.
And so then I got your 29 point.
I think it's about to make
60.
Nice.
Okay.
What's
That's better. That's better.
Anyone who uses a calculator that isn't a Texas 30X,
I use a TI-85.
What did we say it was?
yeah, exactly.
29.
Yeah, sometimes a chicken. Sometimes it's a TI-85.
Alright. You try that one.
Ooh.
Trig function we're going to use.
So,
Sine. Sine of 66 is x over 50.
so
Oh, we're not.
it's just plugging in a few numbers into a calculator. Good old TI-85. The 5 did not.
Yep, it didn't. I see that. 1 second. 66 was our angle, right? $45.68. Questions, comments, concerns, clarification.
There's mud.
There is mud?
Yeah.
Love it. Alright?
Oh.
Wait, can you go back?
Go, talk to me. Good now?
Find the 6 trig.
Find the 6 trig values of theta. Go. Alright, so the first thing we gotta do is we gotta find that missing side, right? So we always have a squared plus b squared equals c squared. So we've got 12 squared plus 5 squared equals c squared. 144 plus 25 is 169. So 13 is c. I don't need the plus or minus there because I can't have a negative side length. Okay? So I don't need the plus or minus in this case, but truly it is plus or minus 13. So the hypotenuse is 13 units. Okay? So the sine of theta is then 5/13, which means the cosecant of theta is 13/5. The cosine of theta is 12/13, which means the secant of theta is 13/12. The tangent of theta is opposite over adjacent 5/12. The cotangent of theta is 12 fifths.
Holy smokers,
I know.
that's a lot of numbers.
Numbers. And it's easy to do them in those pairs because one is just the reciprocal of the other.
Holy
Yeah.
smokes, yeah.
Yes, Joe.
So what are like the cosecant and secant used outside of use?
Some trig, they like to use the trig functions for those because it's, I rarely use them because I just like sine and tangent. I'm with it. All right, one more. Go for it.
Okie dokie.
So I got x squared is 88.
Yeah.
So x is the square root of 88, right? Which is 2 square roots of 22. Yeah?
Yeah.
88 divided by 4 is 22.
Not that guy.
So then that makes my sine of theta 9/13. Cosecant of theta 13/9. Cosine of theta would be 2 square roots of 22 over 13. Secant of theta would be 13 over 2 square roots of 22, or 13 square roots of 22 over 44. Tangent would be 9 over 2 square roots of 22. Luckily, I'm recording this because I'll continue. Normally, I would just quit right here since you all have quit. Which would be 9 square roots of 22 all over 44. And then the cotangent would be 2 square roots of 22 all over 9. Okay?
I gotta go get the